Now I'm going to start the second part, part 2 of the notes, because I couldn't fit it all in one video. So let's have a few examples of how to take limits as x approaches infinity using those guidelines. So if I had something like 2x cubed minus 5x plus 3 over 5x squared minus 7x plus 8 equals, well, I want to look at those leading coefficients, the leading degrees, so those leading terms. So the degrees are different, right? So, and then the top one is bigger than the bottom one, so my limit does not exist for this one. Okay, let's do another example. Let's have the limit as x approaches infinity of, we'll say, 4x to the 5th power minus 7x cubed over 15x squared minus 2x to the 5th. Okay, so once again, like this one is not in order, so I would just rewrite it and put it in order so I can see that leading coefficient be that first one. So that I would rewrite it as negative 2x to the 5th power plus 15x, so now they're in order. And then I can see that it has the 5th power, so they're the same. So when the degrees are the same, all you have to do is use the ratio of the numbers of the leading coefficients, 4 and 2. So 4 and negative 2, I mean. So that would be negative 2. My limit is equal to negative 2. And then if I have a last one, let's do one more. If I had the limit as x approaches infinity of, we'll say, 5 plus x over 7x squared minus 5. Well, again, I would probably rewrite this as x plus 5, so it can be the leading coefficient. And I see that this has a degree of 2, and whereas the first one has a degree of 1. So the numerator is less than the denominator, which means that my limit is equal to 0. And you guys can always confirm these limits on a graphing calculator. Okay? But what happens when you are taking the limit with 2 horizontal asymptotes of a function with 2 horizontal asymptotes? Something like, let me see, asymptotes. So something like the function f of x is equal to 3x minus 2 over the square root of x squared of 2x squared plus 1. So if I wanted to find the limit of this function, the limit of 3x minus 2 over the square root of 2x squared plus 1 as x approaches infinity, well, in this case, I can graph it, or I can look at it algebraically. Okay, so it's like pretty much if you, let me see if I can do this. I need a square pop up. No. So let's just look at this x squared. The square root of x squared. What is the square root of x squared equal to? It's just x. So technically, the square root of 2x squared plus 3 or over 3x over that, they pretty much have the same degree. So what we have here is 3 over the square root of 2. That would be my limit. Okay, that's coming from the right. However, when I am approaching negative infinity of that same function, 3x minus 2 over the square root of 2x squared plus 1, well, in this case, I look at the top guy, the numerator, and if I were to plug in negative numbers in here, they start getting more and more negative. So I can't do that for the bottom because it's a radical. I can't plug in negative numbers here. But what we're going to see is the same thing, except it's going to be negative this time. The negative 3 over the square root of 2. because I am approaching negative. So every time, like, the numerator is going to get more and more negative, but I can't do that to the denominator. So my numerator is negative, which is why we get a negative sign in my answer. And the fact that I can have 3 over the square root of 2 again is because, again, these two leading coefficients, the leading terms, have the same power. Okay? Alright, so also, let's see. Let's take a look at another special limit. Okay, so limit at infinity. So again, you have to know this one again. Know this. If I have the limit of sine of x over x as x approaches infinity this time, that is going to be equal to 0 no matter what. This time it's equal to 0. Last time I told you, the other one that you should already know is the limit of sine of x over x as x approaches 0. That's equal to 1. These are two different limits, but you have to know them both. One where 1 is approaching 0, and the other one where it approaches infinity. Okay? And then let's see, if I have polynomials, if I just have the limit of, say, like x cubed as x approaches infinity, or if I have the limit of x cubed as x approaches negative infinity, these limits are going to follow the end behavior of the function. So the end behavior, look at the end behavior. And you should know what an x cubed function looks like. An x cubed function looks like this. Right, so what's the end behavior? As x is approaching infinity, that's to the right over here, what happens? This is equal to positive infinity. It goes up. And then as x is approaching negative infinity, so going this way, as x is approaching negative infinity, what happens to the end? It goes down. It falls down. So that equals negative infinity. Again, same is true, like if I had the limit of x to the 4th as x approaches infinity, and the limit of x to the 4th as x approaches negative infinity. I know x to the 4th is a positive function, and it's even, so it'll look like this. So as x is approaching positive infinity going to the right, it's also approaching infinity. The end is going up. So and as I'm going to the left, at negative infinity, what happens to the end? It also goes up. So this one also approaches infinity. My limit is infinity. Okay? And then sometimes we'll have this special case where it's just, if I have something like this, the limit of 2x squared minus 4x over x plus 1, I can still find the limit. I say that it does not exist, right? But I can be more specific about about the end behavior. So I can be more specific about what the unbounded behavior is like. And the way that I do that is I'm going to use long division. So again, Algebra 2 skills, long division. Because this function has the same behavior as its slant asymptote. And the way that I find my slant asymptote is by using long division. So I'm going to divide x plus 1, or I'm going to divide 2x squared minus 4x by x plus 1. So I want to match those first coefficients, so I'm going to multiply by 2x. So 2x times x plus 1, I'm going to get 2x squared, and then 2x times 1 is going to be plus 2x, and I'm going to subtract that. So those cancel, and this becomes a minus, so that becomes negative 6x. There's nothing here, so plus 0. Okay, so again, what do I need to multiply? X plus 1 to get negative 6x. I'm going to multiply by negative 6. So negative 6 times x is negative 6x. Negative 6 times 1 is equal to negative 6. Okay, I'm going to subtract this. So that becomes a positive. That becomes a positive. So that becomes 0 right here, and then 0 plus 6 is 6. So I don't need that there. So just 6. So I have a remainder, so plus 6 over x plus 1. And my slant asymptote is this right here. So if I were to graph 2x minus 6, I go down 6, 1, 2, 3, 4, 5, 6, up 2 over 1. So it'll look like this. It looks like a line like this. Okay, so as x is approaching positive infinity, that means it's going this way. What's happening to the end? It goes up. So my behavior here, my limit would be unbounded up, so positive infinity. And if I were to say that same function, the limit of 2x squared minus 4x over x plus 1 as x approaches negative infinity, well, I look at the end behavior of my slant asymptote, and it goes down, so this is approaching negative infinity. And that concludes our notes for today. Goodbye.